Alright, so for part C, we're asked to implement one arg, which takes a scheme expression S. It returns a call expression that would evaluate to the same value as S, calling the same procedures, but which uses curry to ensure that all call expressions have exactly one operand. So, exactly one operand, and it says that call expressions that already have one operand are unchanged. And there are a few assumptions you can make, so assume that S only contains numbers, symbols, and call expressions. Assume that each operator of a call expression is a symbol. And assume that each operand is either a number or another call expression. So that's important to know that we can have nested call expressions. Okay, so this is a really complicated problem, so again, let's just walk through some doc tests. So in the example where we have a call expression that already only has one operand, then we're just going to return the original call expression. In the case where we have one that takes multiple operands, we're going to use curry to kind of break them down into single operand function calls. So, like that. As always, when you evaluate the curried version and the uncurried version, they should be equivalent. And finally, in this doc test, it's kind of the most complicated example where it's just showing that you can have nested call expressions and it should still work out to be kind of correct. Cool. So now let's take a look at the skeleton code and see what we can get from this. So right here, it seems like we have some sort of base case. So if S, the list we're passing in, is just a number, well then we're just going to return S. And then we're doing a let statement, so let num args be equal to the length of the list you're passing in minus 1. And the reason why you have this set as num args is because if you look right here, so abs of 3, this list has a length of 2, and then if you subtract 1, that means you have 1, which is exactly the number of arguments that a 2-element list has, because one of them is procedure and one of them is the operand. Cool. Now, with this kind of variable set, we have what seems to be an if-else kind of structure. So this is your if, and this is your else, and as always, this corresponds to like a base case and a recursive case with recursion. So in this case, where you have the num args equal to 1, meaning that your list that you pass in looks something like this, right? Just the abs of 3. That means that we're just supposed to return the original call expression. So how do you get the original call expression? Well, it's going to be in a list. So, oops. Let's write list here. And then the first element of the list is just going to be the car of your string. Or sorry, not string. I keep thinking S is string, but it's your list. So the first element of your list is going to be, for example, this abs. So you're calling car on S. That's Python syntax. Car on S. And then the second element of your list is going to be your car of your coder of S. So this is going to be like your, I think in lab we defined a coder function, which is equal to car of your coder of S. But I don't think we're allowed to use this for the final, so let's just write it out. So you're basically doing car of coder of S. And the one thing to notice is they already nested this inside another recursive function called to one arg. And the reason why you need this is because sometimes instead of just getting something simple like abs of 3, maybe you got abs of 3 and, or sorry, not abs of 1 plus 2. So this is still going to read it off as having one argument, right? Because this is read as one argument. But it's actually a nested call expression, so that means we have to evaluate this inside first, and the way we do that is by doing a recursive call onto one arg. And just as a side note, I think in the options, yeah, so it tells you that you can either choose cons or list as your blank for A. And the reason why you have to use list instead of cons is because remember, cons has to take in a list as the second argument. So cons, you're going to take some element, and then the rest of it has to be a list. So this has to be a list. And we don't necessarily know that this is going to be a list, right? It could just be an element, which is why we need to use list that doesn't have this kind of restriction. Awesome. So now let's move on to our recursive case. So the important thing to see right here, right off the bat, is that all of this, so these two lines together, they're all just one call to repeated call, because repeated call, if you remember from part A of the problem, takes in two arguments. So one of them is going to be your operator, and the second one is going to be your operands. What a repeated call does is it'll sort of take your operator, so if operator was F and your operands was like a list of 1, 2, 3, it'll basically create a repeated calls expression, which is going to look like F on 1, and then that on 2, and then that on 3. Right? This is from part A of the problem. So with that in mind, how can we sort of generate this shape using these blanks, right? So essentially, I think the best way to figure this out is just to go back to the doc tests. So first I'm just going to erase some of this stuff to make it a little bit easier to see. But specifically, I'm interested in this doc test. So this is the input and this is the desired output. But the reason why I'm interested is because it pretty closely matches exactly what we wrote as an example for what repeated call does. So if you kind of look back and forth, here we have three arguments, right? So this is 3 args. It looks like 4 because you have the plus sign, the 4, the 5, and the 6. But remember, when we defined what num args was, it's the length of the list minus 1, because we don't count that first operator because we're going to use that for creating our 1 arg kind of call. So yeah, basically we can kind of pattern match this because the 4, 5, and 6 correspond to the 1, 2, and 3 in our operands example, and then the sort of plus sign here corresponds to our operator F. So when you call 1 arg, the desired output is going to look like this, where you can again match this where the 4 is the 1, the 5 is the 2, the 6 is the 3, and then this entire expression here is your F. So knowing this, we just have to fill in D and E such that we basically get our operator F here, and we need to fill in F, the blank F, not the function F, such that we get our operands here. All right, so now how do we do this? Well, it looks like in order to get F for this doc test example, we basically need to make a list that contains curry and then the number of args, right? Because you're currying this function and then the function had 3 arguments, which is how you got this 3. So we can do this. Basically, you're going to put in here, we already have our list constructed. So we just need to fill in. Our first element is going to be curry, and then our second element is going to be num args. But remember, since curry is a function, we don't want to have it like evaluate just yet. So we need to kind of quote this just to make sure that it doesn't self-evaluate. So now finally, what do we put for our operands, or like how do we get our operands? So what do we fill in for blank F? Well, in order to get our operands for this example, again, the operands are just going to be 4, 5, and 6, right? And the way you get that is just the coulter of S, because the car of S is this plus sign, and then if you want everything but the plus sign, the 4, 5, and 6, you do the coder of S. But we see here that they've already provided us with the coder of S, and in addition to that, they've said, oh, we need to map some function to that. So remember, map takes in a function and then something that you map the function to. So now the question remains of what function do we want to map to the coder of S? So to answer that, let's kind of recap what we have done so far. So for this example, we have created it such that we got our, I'll erase the highlights and highlight again. We've gotten our Curry 3 plus, right? So that's what was done in this line. So what's left to do is now to have, or to kind of get the rest of this, which is the coder of S, but we can't just get coder of S by itself, because what if the other arguments, like what if the 4, 5, and 6 weren't 4, 5, and 6, but instead some more nested expressions, right? In that case, you still have to translate those nested expressions. So maybe one nested expression is going to be like 1, 2, 3. You still have to translate this to be a one argument expression. So essentially this is like our recursion, where we have to call one arg to every single element inside our original input list. So what we're mapping is our original function, one arg, onto coder of S. That way we go through all of our recursive calls to properly sort of unravel all of our expressions to make sure every one only takes in one argument. Okay, so now with all of these blanks filled in, let's make sure that they're actually options. So for example, this one here, we have list as an option. Here, blank B we said was car of S. And then blank C was car of coder of S. Blank D, something we fill in ourselves, so it's quoted curry. And then blank E was num args. Hold up, where is num args? Okay, there's been an error. Okay, so let's look back in our code. We're saying this code should essentially give us our highlighted region. And okay, I see the problem. So what we've written so far with the list curry num args, this just gives us what's highlighted in blue. So right, so curry of 3. But what we really need to do is append that little plus sign, because that's the operator that we're executing on all of our operands. So I think what should be happening is what we've written already should just be a all combined into blank D. So I'll erase this. So this should just be the list of curry and num args. How do you spell num args? Right, because this gives us our parentheses curry 3. Then we need to make that in another list containing our plus sign. And how do you get our plus sign? Well, it seems like it's just going to be the first element of our S. So we're just calling car of S. Okay. Whew, that was a pretty big mistake. Yeah, good thing. That's why we kind of solved the solution, or like solved the problem, and then double check just so we didn't make any mistakes like that with our answer choices. So this blank D should really be a list, curry, and num args. And then blank E should be, yes, we see we have a car of S. Perfect. Okay, now blank F is one arg. Hopefully that is an option, and it is. Awesome. Okay, so that now is everything in question 4C. And yeah, this was a pretty tough problem. Again, like I said in the previous part, they actually gave us like 4 extra points on the final because this question and part B were too difficult. So don't stress too much if it was like really hard and you didn't get it when you were doing it by yourself. But hopefully this makes sense now.